Hello all, welcome to Machine Coding Interview. I am Sanjay and in this course we will discuss the Bloom filter. So there are generally two kinds of Bloom filter. One is standard Bloom filter and one is counting Bloom filter. So a standard Bloom filter is a probabilistic data structure that is used to test whether an element is a member of a set or not. It is very space efficient and very fast, but it comes with some trade-offs. Like it can have false positives, means it might say that an element is present, but it might not be available in the set. And it never has false negatives, means if it is saying that this element is not available in this set, it means that is definitely not available. But the same case is not true for the counting Bloom filter. So let's see how the Bloom filter works exactly. So for implementing Bloom filter, first we have to initialize a bit array of size m, where all the elements should be 0 in the starting. Okay. Then we are going to choose k independent hash functions that will map the element to the positions in the bit array. After choosing the hash function, we will add the element in the Bloom filter. So for adding the element in the Bloom filter, what we are going to do? We will pass the element through all the hash functions, and for each hash function result, we will set the corresponding bit to 1 in the bit array. Now how do we check whether the element exists in the Bloom filter or not? So for that, passing the element again through all the k hash functions. If all the corresponding bits are set to 1, then the element might be present in the set. But if any of the bit is 0, it means that element is not present in the Bloom filter. So let's see the example of the standard Bloom filter now. So first we will set the initial state of the Bloom filter by taking the bit array of size 10. Okay, and we will be using two hash functions, h1x and h2x, and the formula is x into 2 modulo 10 and x into 3 modulo 10 for the second hash function. So this is the bit array where we are setting all the elements as 0 in the starting, and these are the indexes of all the elements. So first we will insert 7. Okay, so for getting the position, we will pass 7 in the two hash function. So first h1 7. So what will be the value of h1 7? 7 into 2 modulus 10 means 4. And what will be the value of h2 7? 7 into 3 modulus 10 equal to 1. So we are getting two positions 1 and 4. So for 1 and 4 we are setting the bit. So here you can see the result is this. The result is this bit array where 1 and 4 position are set as 1. Now we are inserting element 12. So for element 12, the h1 function is giving 4 and h2 function is giving 6. Okay, so we are setting this bit in the bit array. But since 4 was already inserted, we are not doing anything here. And for 6, we are changing the bit from 0 to 1. Now we have inserted two elements 7 and 12, and now we will check for 17. Okay, so for 17, hash function is returning 4 and 1. Okay, fourth bit is already set and one bit is already set. So this is given 17 as present in our Bloom filter, but which is not true because we have inserted only 7 and 12. So this is a false positive case. Now check for 7. For 7, we are getting 1 and 4 from the two hash functions. So 1 is already set and 4 is already set. It means this is present in our Bloom filter. So this is a valid case where we had inserted 7 in the Bloom filter. Now we will check for 12. So for 12, we are getting 4 and 6 from our hash functions. So we can see that 4 is set and 6 is set. So 12 is also present in our Bloom filter. So 12 is present because we had inserted 12 in our Bloom filter. So these two are correct. Now we will check for 5. Okay, so for 5, the two hash functions values are 0 and 5. In 0, the bit is 0, and in 5, the bit is 0. It means 5 is definitely not present in our Bloom filter. And this is the correct case because we had inserted 7 and we inserted 12, but we had not inserted 5. So this is giving us the correct answer. But for 17, this is giving us false positive. So this is one drawback of using a standard Bloom filter, that it can give us false positives. But definitely this does not give the false negative. Why it does not give the false negative? Because there is no way of setting the bit from 1 to 0. Okay, and because of that, this will always give us correct result if any element is not present. If any element is not present means its bit is not set to 1. So there is no deletion operation which decreases 1 to 0. That happens only in counting Bloom filter. Let's see the implementation of the standard Bloom filter. So this is our Bloom filter interface. So we have three operations: insert, which is taking one string; lookup, which is taking one string and returning a boolean whether the element has found or not; and delete, which is taking a string for deleting from our Bloom filter. Now first we will see the Bloom filter IMPL, which is our standard Bloom filter. So in the standard Bloom filter, as we had already said, that there will be a bit array, okay, and there will be a size. So we are taking the size from the constructor, and then it only supports the insert and lookup operation, but it does not support the delete operation. So for delete operation, we are throwing this unsupported operation exception. Now in the standard Bloom filter, we are taking three hash functions, okay. H1 is first hash function, H2 is second hash function, and H3 is third hash function. All three are taking word, and from the word they are getting the hash code and multiplying it by 7 and taking the modulus by the size. Okay, and the same thing we are doing with H2 and H3. What we are changing here? Just we are changing the multiplier. So here we are taking the multiplier as 13 and here we are taking multiplier as 17. So we are using these three hash functions in our standard Bloom filter for setting and getting the bit positions. So in the first function insert, what we are doing? First we are getting the word, and then in the bit array we are checking from the hash functions. Okay, so this hash function will give us the index of the bit array, and we will check that in that bit array, in that bit array, for this index value is set or not. If it is set, then we are checking for the second hash function, and if it is also set, then we are checking the third hash function. Okay, so from all the three hash functions we are getting some index, and for all the three indexes, if the bit array is set, then we are not going to insert that element because it is probably already present in the Bloom filter. But what happens if it is not present? Then we are just setting the value as true for that positions from the hash function indexes. Okay, now we will check for the second function, which is the lookup function. So what do we do in lookup function? We are checking all the three positions from the hash functions in the bit array. If the bit array's bit position is set for all these three indexes from the three functions, it means that might be available in our standard Bloom filter. Okay, now we will understand how the counting Bloom filter works. But before understanding how the counting Bloom filter works, just understanding the uses of the standard Bloom filters are web caching, web crawlers, and spell checkers. So how do we use in web caching? So in web caching, generally we check it for the static images or for the static files, whether this file is already available in our caching server like Cloudflare or not. Okay, it uses the standard Bloom filter and just check whether that element is available in our Bloom filter or not. If it is available, then our application gets the element from the cache itself. If it is not available, then it goes to the server. And this Bloom filter is also used in the web crawlers. So how does it work in web crawlers? So every time when it gets the URL in the website, it checks in the URL set in the Bloom filter. If the Bloom filter says that this URL has already been crawled, then it does not fetch that URL again. It is also used in the dictionary. So whenever you work in Microsoft Word or PowerPoint, you might have seen the red line in some words. So how does it immediately check whether the word is available in the dictionary or not? It uses the Bloom filter here. So yeah, these are the use cases of the standard Bloom filter. Now let's understand the counting Bloom filter. So a counting Bloom filter is an extension of the standard Bloom filter that supports insertion and deletion by replacing simple bit array with an array of integer counter. So in the counting Bloom filter, we use the integer array which has the counters. So how the counter works? The counter works based on the hash function result. So we pass the input in the hash function, it gives some index, and based on that index, we increase or decrease that counter. So now how to implement this? So for implementing this, we have three functions. One is insert function. Okay. So for each insert function, we increment the counter at the index. Okay. Whatever result we get from the hash function, so from that result, for that index, we increment the counter. And we just do the opposite in the delete. So in the delete, we get some index from the hash function and we decrement the counter at that index. In the query, we check if all counters at the position is greater than 0. It means that element might exist. And if any counter is equal to 0 or less than 0, I think it should be less than equal to 0, then element might not exist. Now let's see some examples. So for setting up the counting Bloom filter, we are taking array size of 10. Okay, so this is the counter array. We are taking the same hash function, okay, h1x and h2x, which has this definition: x into 2 modulus 10 and x into 3 modulus 10. Now first we are inserting 7. Okay, now for 7 we are getting 4 and 1 as the h1 and h2 index function result. So we are incrementing the counter at position 4, which is this, and 1. So earlier they were 0 here, now we have incremented this counters. Now we are inserting 12. So for 12, h1 is giving 4 and h2 is giving 6. So earlier 4th position was 1, so we have incremented it to 2, and 6th position was 0, so we have incremented it to 1. Now we are checking for 7. So since we had inserted 7, let's check the value of 7. So for 7, the hash function is giving 4 and 1. So the 4th position is 2, which is greater than 0, and the 1th position is 1, which is greater than 0. It means this element can exist in our counting Bloom filter. Now let's check for 17. So for 17, the hash function results are 4 and 1. But for 4th position, the counter value is 2. And for first position, the counter value is 1, which is greater than 0. It means that this element might be present in our Bloom filter. But we have never inserted 17. Still, it is giving us that this element might be present. So this is giving us false positive. Now let's check one more case, which is false negative. So for false negative, we are deleting 7 in our counter array. Okay, so what position do we get for 7? So for 7, the position is 4 and 1. So from this array, we are reducing the counter for 4 and 1 position. So this will be 0 and this will be 1. So here this is 0 and this is 1. Now we are deleting 7 again. Okay, so here you can see this position will be -1 and this position will be 0. So this is -1 and this is 0. Now check for element 12. So for 12, the indexes are 4 and 6. Okay, so you can see that 4th is already 0. Okay, so if any of the counter is 0 or less than 0, it means that element is not present in our Bloom filter. But we had inserted 12 and we had not deleted it. Still, our Bloom filter is saying that this element might not be present. It means this is false negative. So this is one drawback of using counting Bloom filter, that it can give us false negative as well as false positive. So this is a trade-off of using a counting Bloom filter. But this false positives and false negatives happens rarely if you are taking a big size of the counter array. For the small size, there might be collision, due to which you will get the false negative and false positives frequently. But for the large size of the counter array, you would rarely see this false positive and false negative. Now let's see how we can implement this counting Bloom filter. So for counting Bloom filter, we are implementing this Bloom filter, okay, and we are taking one counter array. Remember, in the standard Bloom filter, we were taking the bit array. So here you can see that this is a Boolean array. But in counting Bloom filter, we are using the integer array because we need to store the counters. Okay, and we are creating one constructor. In the constructor, we are taking the size and we are assigning the size, and then we are initializing the counter array by integer array object. Then in the insert function, we are checking the counter array. And here also we have three hash functions h1, h2 and h3. And all of them are having the same implementation, okay, which has one multiplier 7, 13 and 17. And then we are taking the modulus of size. Then for insert, we are checking if all the counters in our counting Bloom filter is, this should be greater than equal to 1. If all the counters in our counting Bloom filter is greater than 1, it means this element is already present in our Bloom filter. And if this is not true, means if any of the counter is set as 0, then we are going to increment the counter for all the hash functions. Okay, and after run we are showing this message that this element is inserted in the Bloom filter. How do we check if a particular word is available in our counting Bloom filter or not? So for that we would simply check if the counter is greater than 0 in all the three positions or not. Remember, it should be an AND condition because we are checking for all the three positions from the hash function. Now for deleting, what do we need to do? For delete function, we are checking three counters, and if any of the three counter is less than 0, it means that element is not available in our counting Bloom filter and we are showing this message. But if all elements are greater than 0, it means that element is present and we will reduce those counters. So you can see that we are reducing all the three counters and then we are showing this message. Okay, and now let's see the demo of the Bloom filter. So here in the main function, we are just creating a Bloom filter. Okay, so here in this Bloom filter, we are taking the standard Bloom filter implementation and this inputs we are giving in the Bloom filter. Okay, and one by one we are inserting this element in the Bloom filter. Now the second example is for the counting Bloom filter. In the counting Bloom filter, we are inserting first cat, dog, deer and rat. And after inserting all these four elements, we are simply printing. We can remove this statement. And after inserting this four element, we are just deleting cat twice and then deer twice. Let's see the output of these statements. So here we can just use system.out. So here you can see that this comely is already present in the Bloom filter. So let's see, are we inserting comely twice? So here we have comely and no. So we are inserting comely only once. So this we can say that a false positive case. Okay, so in the standard Bloom filter, we get the false positive case because our size of the Bloom filter is only 100. So there are lots of chances that we will get the false positive in the standard Bloom filter, but we will never get the false negative here. Okay, now if you increase the size of the Bloom filter, then you will not see this error. So here you don't see that error. Okay, yeah. So you don't find any false positive case when you increase the size of the Bloom filter. Now we will check for the counting Bloom filter. So in the counting Bloom filter, we are inserting cat, dog, deer and rat. After we have inserted cat, dog, deer and rat, we are deleting cat. So cat has been deleted from the Bloom filter. Now when we are trying to delete cat again from the Bloom filter, it is saying sorry, cat is not available in the Bloom filter because we have already deleted cat from the Bloom filter. And the same thing is happening for deer. Okay, first it is saying deer has been deleted from the Bloom filter, and when we are deleting it for the second time, then it is saying that sorry, deer is not available in the Bloom filter. Okay, so these are the examples of the standard Bloom filter and counting Bloom filter. So the counting Bloom filter is something that we are going to use in our Truecaller application. So let's see how we can use the counting Bloom filter in our Truecaller application. So that's it from this video. See you in the next chapter.